Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Let us continue our study of chemical reactions and stoichiometry. In this lesson, we will learn about the importance of chemical changes. Chemical reactions bring about chemical changes. In other words, the original substance is changed into one or more new substances with different properties. All chemical changes are accompanied by energy changes. This energy is usually in the form of heat, light, or electricity. Let us pause and perform the first activity of this lesson. Gather in small groups and work together to identify some examples of chemical reactions that produce chemical and energy changes. There are plenty of examples from your everyday lives. Talk together and see if you can identify some. Please, go ahead.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, everyone. Were you able to come up with some examples of chemical reactions that produce energy changes? Good for you. There are many that occur naturally all the time. Photosynthesis is one. It is the chemical reaction that takes place in plants. Plants use energy from the sun to change carbon dioxide and water into food that plants need to survive. This process is also important to us. We need to eat those plants to survive. Photosynthesis is an endothermic reaction because it would not happen without an external source of energy, which, in this case, is sunlight. Breathing, or respiration, is another example. Respiration is the chemical reaction that happens in our bodies to produce energy for our cells. The glucose in our bodies reacts with oxygen from the air we breathe to form carbon dioxide, which we breathe out. It also reacts with water and energy, which we need to survive. Breathing is an exothermic reaction that takes place when compounds within the food we eat react with oxygen we breathe in. Energy changes produced by chemical reactions have many practical applications or uses above and beyond those that keep us alive. Combustion, which is a fancy name for the burning of fuels such as gasoline, coal, and oil, is an obvious example. When we burn these fuels, they release huge amounts of energy. We use this energy to power the engines of vehicles and machines. We also use this energy for electricity. How? Combustion produces heat energy that changes water to steam. Pressurized steam then runs a turbine that generates electricity. These reactions also produce tremendous amounts of carbon dioxide in the air. Combustion is another example of an exothermic reaction because of the energy that is released when the fuel is burned. Chemical reactions are also important in many types of heavy and light manufacturing industries. Steel is a good example. Steel is used throughout the world in many ways. Can you imagine life today without steel? I know I cannot. Limestone is broken down by a chemical reaction to produce quicklime and carbon dioxide. Quicklime is used to remove impurities in making steel from iron. It is also used to neutralize soils that are too acidic, making them easier to use in farming. However, the limestone must be heated in a kiln at a temperature of over 9,000 degrees Celsius before the chemical reaction takes place. Here is a fun example. Have you heard of light sticks? They are used by divers and campers and by kids who just want to have some fun. The light stick is a plastic tube with a glass vial inside it. To activate a light stick, you bend the stick, which breaks the glass vial. Breaking the glass vial allows the chemicals that are inside the glass to mix with the chemicals in the plastic tube. These two chemicals react and release energy. Fluorescent dye in the stick changes this energy into light, causing the light stick to glow. This reaction is not as important as breathing or photosynthesis or combustion, but it shows us that learning about chemistry can be kind of fun. This chemical reaction is an example of an exothermic reaction. Chemicals mix together to release energy. Let us pause and perform the second activity of this lesson. Burning a log and frying an egg are examples of chemical changes. What are the chemical changes that occur when you light a log on fire? What are the chemical changes that occur when you cook an egg? Please go ahead and answer these two questions. Teacher, please help the students if they need it.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, everyone. Were you able to come up with answers? Good for you. Would you like to hear my answers? Good. When you fry an egg, the liquid egg white part of the egg changes color and becomes solid. The cooked egg has properties that are different from the properties of the uncooked egg. When you burn a log, you can see the log getting smaller and smaller. You can also feel the heat and see the light that the burning log gives off. You also see new materials, such as ash, that collects beneath the log, and smoke that rises from the log. That is all for this lesson, students. You learned about energy changes and chemical changes in chemical reactions. And you learned about how important those changes are to our everyday lives. Good work. Until next time, thank you, teacher. Thank you, students.